The quantity theory of money explains the relationship between the money supply, real GDP, price level, and velocity of money, which is simply how quickly money is circulated within the economy. This is shown through the equation MV is equal to PY, where PY is a price level measured by index multiplied by real GDP. So PY in this case is the same as nominal GDP, as it is GDP measured in terms of a certain price index. Let's use an example to illustrate this. We'll take a hypothetical economy where the money supply is $10 billion, the real GDP is $100 billion, and the price index is 1.5. We can manipulate the formula to solve for velocity, price times output over the money supply. You can see that the final result is 15, meaning that the average dollar will circulate or switch hands 15 times within the year. Let's say we want to solve for inflation in the long run. There are a few assumptions that must be made. Firstly, we must change the quantity equation to reflect growth rate. Therefore, we will use value showing the percentage change in each variable. V will be held constant, so the velocity growth rate will be equal to 0. Finally, the growth rate of the price index will be equal to the expected inflation rate, and will be substituted accordingly within the equation. You can see these changes down below. As you can see, our final result shows that the inflation is equal to the money supply minus real GDP, meaning that inflation occurs when the money supply grows faster than real GDP. The Fisher equation is listed below, but it can also be rewritten this way. So let's take it in this case. Real interest rate is equal to nominal rate minus inflation rate. If inflation were to increase, that would mean a decrease in the real interest rate, or a decrease in the real return. This means that lenders will increase interest when inflation is high. So let's apply that to this equation here, or the way that we have written our equation here. If this is the case, this means nominal interest rates will rise with expected inflation. Therefore, the nominal interest rate and expected inflation rate will rise and fall by the same amount. Let's tie all of this together. In the long run, we can assume that a rapid increase in the money supply will result in higher inflation. When inflation rises, nominal interest rates will rise accordingly. Okay, so finally let's take an example, solving for nominal interest. In this hypothetical economy, the money growth rate is 3%. The change in velocity is 2%. The output growth is 4%. And real interest rate is 3%. We'll have to use quantity theory to calculate for expected inflation. So let's substitute our values accordingly. We'll have the money supply plus velocity minus GDP. So 3% plus 2% minus 4%. Expected inflation is equal to 1%. Finally, we'll solve for nominal interest by substituting our values into the Fisher equation. As you can see, the real rate is 3%, as was previously specified in the example there. And our expected inflation is 1%. So, nominal interest rate is equal to 4%.